talk to you about what we are doing in our cluster. We are using Foreman and Puppet. And I'd like to show you our chosen best practice. There are always many ways to do things, and I'd like to show you how we are doing it using Puppet and the Foreman. One reason why I'd like to present this is to seek collaborations. Well, we are all solving the same problems, and I think many of you are using Puppet too. So let's come to the agenda. A very short introduction, what is Puppet and Foreman. I think most of you know what this is. Then we'll talk about configuration management in UBELIX, the big picture first. And then one of the more important things for me is how do you do Puppet and configuration management in a team? How you can make sure that you can work together and do not override each other and all this. So you have to have some kind of a workflow. And then I will talk about roles, profiles, and data pattern, how we do it, and some words about collaboration. So now you're out, audience. Who is using Puppet in production? So not that many. Who is planning to use Puppet? Okay. And who has already played with Puppet on a laptop? So most of you know what it is. And, huh? It's like we heard in the last presentation, always take the one tool that fits you. Don't just to take a tool and use a hammer to implement it in your environment. Ansible is good too. I have a look at about 4 tools and stick to Puppet because I already used it in my former job. Simple as that. And who is using other configuration management tools? Okay, and I don't ask who is not using any tool. So what is Puppet in a nutshell? It's a configuration management tool written in Ruby. It's for automating IT operations. It uses a declarative domain-specific language, and you can use it standalone on every client, or you can set up a client-server environment where you then have a Puppet master. How does Puppet DSL look like? At the bottom, you can see a simple example using 3 resources. You have a package resource that installs OpenSSH server. Actually, this works only on Debian, unlike Ubuntu, Linuxes or Ubuntu. Then you have a file resource, placing the daemon configuration file and setting some mode. And the last resource is the service resource that actually makes sure that the daemon is started at system boot and is always running. And then you have those fancy arrows. For example, this one means if the file resource is changing, restart the daemon to take up the new configuration. That's Puppet in a nutshell. Nothing more, nothing less. And the art is how to organize all those snippets and make them platform independent. And what is Foreman? Foreman is a tool which endorses the Puppet master. So you have those features already on board. And on top of them, it's actually a complete lifecycle management tool. It's able to provision systems, be it bare metal, be it virtualized. So it can bring up hosts, run Puppet on them to provision them. And as such, we use it as an external load classifier for our Puppet code. Nothing more. What you also get is host monitoring. You can see at any time if the configuration that is managed, not all configuration, only what you manage, if the configuration has changed. Be it your colleague that has changed something directly on a host, it gets reverted. You will see it here. So that's a nice thing too. The big picture, how we are using it. On the top left, you see this box where I have a virtualized Foreman and some hosts. I call it the Pocket UBELIX. Here is our development environment. So Nico and I are working on our laptops and producing Puppet code and generate configuration in the development environment. We push and pull to our stash server, so everything we do is version controlled. For us, that's important. And in UBELIX, we have another Foreman, our Puppet master, that currently manually, but we could automate it too, pulls changes from the stash server and applies it accordingly to UBELIX, be it in testing environment or production environment, and come to that in a moment. So that's the big picture. So as static environments, no, false. We are using dynamic environments. We want to be able to generate environments on demand and throw them away, but 3 of them are always present. Development means what we are doing on our laptops virtually. Testing and production are within UBELIX. Testing environment, some nodes in UBELIX, we are doing canary testing. Some nodes in UBELIX are in the testing environment. So when we merge our changes into the testing environment, only those nodes are affected. If things go wrong, not the whole cluster is down. And if things are green, we can merge into production. And it gets rolled out to all servers. To get to the top, our tooling is hiera and stash. Everything begins with a ticket. Tickets like, we should have a module for this service. We should change the configuration for this and that service. So it always begins with a ticket, and off the ticket we create a feature branch or a bug fix branch within our repositories we have. And on our laptops, we change to those branches, fix the stuff, merge it back to development, and we don't only merge, we actually do pull requests, and the other part has to review the code. So we are actively doing 4 eyes principle, wherever possible, whenever possible. It's a bit difficult when one of us 2 is in holiday. If all is good, we merge into development, and this is something like integration testing. As soon as it is in development environment, it gets applied on all those servers we have virtualized on our machines, and then you would find failures between the modules. If you change one module and breaks something else, you would see it here. And if this is good, we merge to testing where it goes out to UBELIX. That's the workflow in a nutshell. We try to keep it as simple as possible, but though we want some safety. What is Pocket UBELIX? Pocket UBELIX is a virtual environment. We are using VirtualBox together with Vagrant, I think tools that you all know. We also do testing with RSpec and Beaker. I'll tell you some more about that later. We like to have it as close to UBELIX setup as possible, so we have host-only network adapters building the same networks as we would have in production. So same IPs, all the same. Although the setup is limited, we can't do any virtualized games with InfiniBand hardware or the like. So it's not possible to simulate all on this laptop. And below you can see the state of my Pocket UBELIX. It's actually no problem to have 9, 10 Linux servers running on this laptop. It works good. Still fluent. So the question is, going back to the big picture, how are those Git repositories deployed to the Foreman, to the Puppet master, respectively? We are using R10K. That, meanwhile, is a standard way to do that. It's endorsed in the Puppet stuff, meanwhile. The point is, every Git branch becomes an environment. So in our Puppet repository, the Puppet env we call it, we have 3 branches that are always present: development, testing, production. And when R10K is run, you can see the command up there. It will make a directory out of every branch it finds. So when you add another branch, feature XY, it will become another directory on the Puppet master. So we have dynamic environments. Another aspect R10K is doing for us, module dependency. Here you see an output of our current Puppet module file. It goes further. Here you define which Puppet modules are used by your environment in which version. We do fix the versions because we don't like surprises. Most of the time we do not need new fancy features because the current version of the module does exactly what it should. But when needed, we can see we then see, okay, there's a bug fix for a bug that we encounter, so we can upgrade to another version. It's our need for, let's say, control. That's why we fix the versions. Actually, also for our own modules. Let's come to roles, profiles, data pattern. Something that is propagated since about 2 years or even more. This scheme is, or this picture is from a presentation of Greg Dunn, Advanced Puppet Design. On the bottom, you have the resources. That's what we saw at the beginning: files, packages, and the like. And those are combined together, then represented by modules. Let's say you have a module for SSH, you have a module for CVMFS, or you have a module for OpenLDAP. Those are, let's say, the service modules. On top of that, we are using profiles. And we consider profiles like technology stacks. Let's say a profile LAMP server. What do I need? I need the module Apache, I need module MySQL, I need some configuration for that. So this is endorsed in the profile. And on top of that, we have roles. Our server, each server that we have has a specific role, exactly one. Roles could be an ArcCE server, a compute node, a submit node, a front-end node. So any role that you have in your environment. On the right, you see where data is coming in, configuration data. On the top, you have the classifier. That's our Foreman, the external load qualifier. This one says this server has this role. That's exactly what classification means. And below, you have the configuration data as is, and this is coming in on the level profile or module. We don't use configuration data in the roles. Roles is an abstract concept. We will see it. So, all together, can you read it? I hope it's big enough. So, on the top left, you see the hosts list. And let's take the grid admin. It's belonging to a host group infra-servers grid admin. So all our servers are nested in host groups. Why? We don't want to define variables or values on every node. We don't like click orgs in web GUIs. That's always a pain in the ass. So we decided to do it by host groups. And on the host group infra-service grid admin, we have set 2 variables, role, subrole. Those are available later when Puppet is run. Then we have our configuration data. If you use hiera, you have a hierarchy of YAML files where data can live. And you see there's the third position, subrole, role, subrole, points to that file for the given group. And there it is. That's the node classification. On a grid admin, because it's belonging to the grid admin, host group will include this class. And then it starts. So that's the combination of Foreman and Puppet Master. Everything else is in the Puppet Master code. And version control. So up there, putting hosts into host groups is all we do in the GUI. Everything else is code. So we use role inheritance. On the top, you see the role, a front-end server grid. That's our argce. So apparently, yes, it includes a profile argce that's specific for this role. But a front-end server grid is also a front-end server. But apparently, in the middle, we do not have special things currently for front-end servers in general. But all servers are also base. Also have the base role, and there you can see postfix, OpenLDAP client, Ganglia, Gmod. So all tech profiles you see here, you can say every server in UBELIX have those resources on them. So this is some sort of documentation on a high level. You see, where do we have postfix? Apparently on every server. Same for Gmod. You now know where the stuff is, but you have absolutely no idea how it is done. So this is an abstraction layer on top. Here we have two profiles. On the top left for ShellDAP, and on the top bottom right for CVMFS. This is a tech profile, we call it. So here we can see for CVMS, for instance, we fetch configuration data from hiera, the cache-based directory. We make sure that the directory is created. If it's not, it gets created. And then we install CVMFS here. And finally, we do some mount points. Those are configured in hiera. So that's a recipe how to install CVMFS. Then we come to the configuration data. That's some lines of our common YAML. So those configuration data that is general for all. And here we can see the configuration data for CVMFS. Here we can see which version do we want to install, how much quota limit do we set, where's the cache base, which mount points do we want to use, and which HTTP proxy do we use. So if things change, we won't have to change our profile or anything else. We only have to change the configuration data. And it gets rolled out to all compute nodes. We have seen here, we simply include this class CVMFS and are not giving any parameters. That's a new feature, new, it's not new anymore. It's called automatic parameter lookup, data binding, and this is available since Puppet 3, and it's a good thing. So we are very slim here. Just include CVMFS, and all those parameters that could be provided are automatically mapped to what is found in the hiera file. If it's found, it will get into the class. If it's not found, the default is taken. So you have to have less to write, less boilerplate code. That's to the configuration data. And the question now is, you have a lot of code. Could you share that with me? And most of the time, people say, OK, I can give you our modules. They have no secrets in it. Most of the time, site-specific stuff have secrets in it. And for guarantee that the configuration data is closed. And we wanted to have a solution that we could also give you the configuration data. So where do we put the root password, for instance? Still in hiera, but we encrypt it. That's a nice little plugin for hiera. It's called eyaml. It does inline encryption of sensitive data only, so you still can read the file for most of the stuff, except for those parts that are sensitive, that are closed. It uses a public-private key encryption. So the Puppet master needs the private key to decrypt it at runtime when it builds the catalog, and you need it locally when you decrypt stuff or on-the-fly edit stuff. It's still possible to write edit a certain file, and VI opens, and the buffer is unencrypted. And as soon as you save, the file gets encrypted again. It's quite nice. So, and where do we place that code? We have chosen that every component module, like NTP, SSH, CVMFS, that is not site-specific, that is possibly useful for all, should live in its own repository. It makes it easier to pull requests, to open it for you, to clone them. For the site-specific Puppet code that is really only useful within UBELIX, we created an own repository, UBELIX site, that is actually a module too. We come to that later. And there we store site-specific stuff like roles, profiles, custom templates that are only useful in our environment. And then we have another repository, the Puppet environment, where you have already seen where we have those environments, development testing, configuration. In this repository, you will find the hiera data, the hiera YAML, the Puppet file with the dependencies to the modules, and our site PP. And this is the repository that actually is pulled by R10K. Everything else is pulled from Git when R10K investigates this repository. So this is the top repository. And it's the only thing not being a Puppet module. And I mentioned that we are doing tests, 2 possible tests. This one is a so-called offline test, if you want. Top left, you see this domain-specific language to write codes. It's rspec, so it's readable, human readable. You can see what it does. It is expected to contain RAM repository EGI trust anchors. And on the bottom right, you see the output. And the nice thing is, you see if it works, even for different, the tests are done for different operating systems. And you also see, apparently, my tests are not good enough. This resource is not tested. It's fast, but it's only building a catalog on checks if the resources are there. Nothing is applied on any server, it just checks the catalog if it's compiled correctly, if it does compile actually. And there's a counterpart, beaker-rspec, that is slow. Looks the same, more or less. And this one now builds up a virtual machine and applies my Puppet code and looks if the resources are effectively set. Is the package installed? Is the file there? Has it the right content? Are the permissions correct? So that's an online test on a real server, though virtual, but it's a real test. And one question that was quite crucial for us too, and I think most of the people are doing wrong, when do we do our own module? When to module? And I believe that you have this tree that you have to answer yourself. Is there a module on the Puppet Labs Forge? Are there still already modules that could solve my problem? And then, if there is not, you have to run yourself. If there is a module, check it, use it. Is it good? If yes, use it, go into production. If it's not quite what you want, is it fixable? Can we do pull requests? Does the maintainer react in a timely fashion? If yes, don't go for yourself. Use the existing module. Improve it. Send send pull requests. Because module maintenance costs. It costs you time. You have to do tests. You have to write the code. So it's always easier to use a module that is there and to improve it than to write the own module from scratch. So second last slide, collaboration contributing. Several groups are using Puppet in Switzerland, also in HPC environment. We have similar challenges to solve. We manage same services. And for me, at least, it's always the question, how do others do the stuff? What solutions have they found? Should I write a module for ArcCE, or has anybody else already done it? And most of the time, I can't find anything. Come to that later, but for me, it's a chance to learn from each other, how to do things. That's why I presented how we are doing it. And we are currently setting up an open source stack using Confluence, Jira, and Stash, and we will put all our Puppet stuff online, open for all. You can self-register, you can use the stuff, you can do pull requests. So maybe this is a starting point for a broader collaboration in Puppet management of infrastructure. And what I have found is a huge documentation, a user guide from CERN. Apparently, they have a huge configuration management system based on Puppet and most of the best practices. I can see the user guide, the documentation, but I can't see the code. Apparently, one needs a CERN account and other things. And if anybody knows any chance for me to see behind the curtains, that would be great. Last but not least, some links to the stuff that I presented. And I think it's time for questions and answers.